Hello everyone, I am Emmanuel Adeoye, AWS Solutions Architect. Today, I'm going to demonstrate how we architect production-grade, high available applications on AWS using Elastic Beanstalk. We will transform a simple web application into an enterprise-ready autoscaling infrastructure. Instead of manually piecing together EC2 instances, load balancers, and monitoring, which introduce operational overhead and potential misconfigurations. We will leverage managed orchestration to demonstrate a fault tolerance architecture in minutes. Autoscaling architecture. What you are looking is more than just a diagram. It is highly available autoscaling web infrastructure that follows AWS Web Architecture Framework principles. Let me break down how each service works and how they integrate to create this resilient system. Here, the Elastic Beanstalk. This is our orchestration engine. It automatically handles deployment, capacity, provisioning, and health monitoring. Think of it as the conductor that manages all the underlying infrastructure so that we can focus on our application code. The next one is application load. It's application load balancer. That is our traffic distributor. It performs health checks, routes traffic across multiple availability zones, and ensure no single instance gets overwhelmed. If an instance fails, it automatically removed from service. Here is the autoscaling group, our elastic capacity manager. It maintains 2 to 5 EC2 instances based on real-time demand. When CPU utilization crosses 70%, it scales out. When it drops below 30%, it scales in. This gives us both high availability and cost optimization. Here, inside the autoscaling group, our EC2 instances run the actual Python application. They are distributed across multiple availability zones. If one zone fails, instances in the other zone keep serving traffic automatically. Now the CloudWatch. So this CloudWatch, we call it this is monitoring and automation. CloudWatch is our monitoring nervous system. It collects metrics, triggers scaling events, and provides real-time visibility. When CloudWatch detects high CPU, it checks autoscaling to add capacity, creating a perfect automation loop. In conclusion, this architecture demonstrates cloud excellence, transforming simple web application into enterprise-grade services. It is not about complexity, it's about using AWS managed service intelligently to build scalable, resilient solutions. Uploading our Python code and configuring the environment. Notice how I'm setting the minimum instances to 2 and maximum of 5 for autoscaling. Let's see how we can configure the autoscaling. First, let's look for Elastic Beanstalk. Now, click on Create Application. Now, this is the configure environment. Step 1. Step 2 is configure service access. Step 3 is optional but it's important. Step 4 is also optional. We look at it. Step 5 is also optional. We have to do some settings there too. So let's start with step 1. Now look at it, environment here. Now we have to choose the web server environment. The reason is that we are deploying a web application that serves HTTP requests. So we leave this as it is. the application name. Now we can call it MySQL. Yes, we can call it MySQL demo. So as long as you have entered the application name, automatically environmental name will appear. Now here, the domain, here on the domain, like you see, leave blank for auto-generated value, so we don't need to do anything there. The platform, this platform is very important. Here, what I want to use is Python, and platform branch, this is okay, and this is okay. So now here, the application code, I have to upload my application. So I have here the version label. Yes, you can name it the V1 initial deployment. So depending on what you want to name, then you click on local file to upload your code, your Python code. As you can see that I choose Python here. So it just depends on what you want to use, what kind of application you want to upload. So if it is Go, you click Go. If it is Docker, we all know what Docker means, all those Kubernetes application, PHP, Node.js, Java, but in my own case, it's Python. So now let me choose my file. Now this is my file, zip file, attached, very good. And here, this presets, here, it's very important to choose high availability. High availability is that it automatically configures load balancer, the auto scaling group, that's to your 2 instances, multi availability zone deployment, all the scaling feature we need. So it is very important. Now the next one, let's look at the next one. Now the next one is configure service access. Now if you look at this service role, so this service role allows Elastic Beanstalk to call other AWS services on your behalf. It also manages EC2 instances, CloudWatch, and auto-scaling. Now as you can see, this is my AWS Elastic Beanstalk service role. So I have this role already, so you can create one here. Now the next one is EC2 instance profile. Yes, so this one too, I have it already, so you can actually create one. This EC2 instance profile gives your application running on EC2 permission to upload logs to CloudWatch. Now this also gives you access to S3 buckets, so use other AWS services. Now the next one is this EC2 KPI. So as you can see, it says optional. So to me, I believe it is important because it allows you to use SSH access to instances for debugging, logging, troubleshooting. Now what I mean by SSH is secure shell. The secure shell is connect to and control remote computers. In this case, your EC2 instances running in AWS. So if your app fails to deploy, you can SSH it to check the log and fix the issues. So the risk is, if something goes wrong, you have to terminate and recreate the entire environment to add SSH access. So it is important for me. I believe it is important. Now I have my own EC2 API already. So so if you don't have one, you can create. So let's click next. This step 3, set up networking, database, and tags. Now for auto scaling, we keep the networking simple and skip database. And skip the database since we are focusing on core Elastic Beanstalk features. Now here, which is VPC settings. So we leave, so because already configured with internet gateway, proper routing tables, and multi availability zone subnet for high availability. Now let's look at the IP address. We click on enable IP address because it enables easy access to test your application, so it is important to enable IP address. Now instance subnets, so we have to leave it because the default VPC, the default VPC will automatically select subnet across availability zones. Now the next one is database. Now I have to leave the database unchecked. The reason is that we are focusing on web application scaling. Adding database will complicate the demo and incur additional costs. So now tax. So this tax is good because it's better for resource management. So we need to add tags like the key. Now you can say project. So why the value is, don't know the value, that's Elastic Beanstalk. Now let's add another one, which is environment. Let's call it environment. So the value will be, let's say demo. Let me call it demo. Let me add another one, the owner, so which is my name. I can use my name, so like I said earlier, that is better for resource management. So that's it. So let's go to next one. Configure instance traffic and scaling. Now here, this is where we configure the auto scaling and load balance. Now the first one is root volume, to keep it default. Now the next one is Amazon CloudWatch monitoring. So I prefer 1 minute. That is, it's okay to see metric faster. So now the EC2 security groups. Here, Elastic Beanstalk will create one automatically. This EC2 security groups. So leave it. Now capacity. You see this auto scaling group, load balance. So these are okay too. Now fleet composition on demand is a good choice too. Architecture, yeah, I prefer this one because it's compatible with everything. Now here, instances type, I prefer this T3.micro because it's free tier. It's free tier, and then this one as backup for it. So this is a great choice. So these are defaults. Availability zones, any. Now let me go to scaling trigger. So the metrics, I prefer to choose CPU utilization. So the statistics, prepare my statistics in yes, average is good. Now the units, I prefer the units as percentage. I want the percentage. Now period 5 minutes is good. 5 minutes is good. Now this upper threshold, so I prefer to use 70 the reason why I use 70 is to scale out when CPU is greater than 70%. You can see that I choose percentage here. So that is the reason why I choose percentage here. So now the next one, that 30, I will choose 30%. That is to scale in when CPU is less than 30%. So this okay to scale down increments, that's -1. Now here, so dedicated is best choice because I'm just creating it for this environment. Now listeners, so leave this as default, keep default rules. Now log file access, so I will check log file access because it enables store log, that it is great for monitoring and debugging. So ask me to choose my S3 bucket. This is it. So now next one, the next step is configure updates, monitoring and logging. Now this health reporting. So the reason why this enhanced is a great choice is it provides details health metrics. So it's a very good choice. Now the CloudWatch metric instance, so I can use CPU, user, a latency, and instance health. So I choose that 3, and then I can use the request. So now I should leave this. So the reason why I have to enable this log streaming is that it's great for monitoring and troubleshooting. So now the next one is manage. So I leave it as default because this one keeps your environment secure and update. Now the next, the email notification, and you enter your email if you want notifications. So now this rolling update and deployment. So this one gives zero downtime deployment, so it's very good. You can choose rolling, then percentage. So the percentage I can just use 50, so that is half instances at time. So half instances at a time. So the next one, so I have to enable this. Yes, I have to enable this on time. I can choose 1 instances and 5 minutes between batches. No, yeah. Yes, when I set 5 minutes, the batch, I can choose batch 1 and then the minimum capacity to 1 for the instances. So now the next one is process server. Yes, this is a good choice. Process server, that's NGINS, that's a good choice. So I have to leave this as default. So now S3 log storage, the rotate log, this one I have to enable it because it's essential for debugging and monitoring. And yeah, instance log streaming to CloudWatch logs, I have to enable this one too because it's streaming to CloudWatch. So the next one I have to leave this as default. So now next, so this where I can review my settings. So these settings show detailed health status in dashboard, provide better CloudWatch metrics. You can see anywhere I want to anywhere I want to edit my settings, I can just click edit. If it is on step 1, if it's on step 2, just click edit. Okay, that's all. Now create. Now, as you can see that the Elastic Beanstalk is launching your environment. This will take a few minutes. Now I have my environment ID. Now if you can see that the platform that I choose, which is the platform, which is Python, you can see it here. Event, health, logs, monitoring, alarms, manage, update, and my tags. In conclusion, we have transformed a simple web application into production-ready, enterprise-grade service that embodies AWS well-architected framework principles. We have demonstrated that strategic cloud architecture is not about complexity. It is about using managed services intelligently to build scalable, maintainable, and cost-effective solutions. This foundation can now evolve into containerized microservices, serverless architectures, or global deployment, all while maintaining the operational excellence we have established today. Thank you for watching, and remember, great cloud architecture enables business innovation.